Leetcode 35, search insert position. It's an easy one. The problem is, given a sorted array of distinct integers and a target value, return the index if the target is found. If not, return the index where it would be if it were inserted in order. You must write an algorithm with big O of n, big O of log n, runtime complexity. Example 1, we're giving numbers, we're giving target, and we are supposed to find target in this array. So we have 5. So if we scan, we would have 5 at index 2. We return 2. Here, same thing, target 2. We scan, we are not able to find target 2, but we return 1 because 2 could take the place of 3, and we can shift everything to the right and it still be sorted. So that's where it should be inserted. So we're searching for where the target could be, or where it could be inserted. So another example, 1, 3, 5, 6. Target 7 is not present in the array, but it could be inserted in 0, 1, 2, 3, and 4. The next index will be 4, where it could be inserted. Okay, we can implement binary search for this problem, but it will be a binary search but with a twist. So if the target isn't found, the left pointer ends at the index where the target should be inserted to keep the array sorted. So we're going to do classic binary search, but if we find it, we return the index. If we are not able to find it, we will return the left pointer because that will represent where it could have been inserted. So quickly, okay, so we are implementing binary search for this problem, search in position. So we will use pointers left and right to represent the boundaries of the array, and then we'll run a loop equal to, because we need to search at the same index when both pointers meet. Okay, now we get a midpoint to the array. We'll do left plus right minus left for integer division, and this is to avoid integer overflow for very large numbers. So now we compare and see if our target is at this index. So if the number at this index equals target, then we found the target. So what we need to do is immediately return the index. If the number at that index mid is greater than the target, then we need to search at the left. We need to search at the left part of the array, and we do that by choosing to reduce the midpoint. We set right to mid minus 1. Now the last case is when the number at that index is less than the target. So we need to search at the right side of the array. So we do else to take care of that case, which is the last condition we have. So we do left equal to mid plus 1. And then when the loop finishes and we're not able to find the target, we would return left, because that would be the position where the target should have been inserted. Okay, so the left pointer, we're returning left pointer because the position where the target should have been inserted would match at that left pointer. So for example, we're looking for, let's take example 2, we're looking for 2. We break the array into 2 and we get index 2, and then 2 is less than 5. We reduce right to 1, mid minus 1, 2 minus 1 will be 1. So now we're searching these 2. Index left is still at 0. Then we choose again, chose midpoint was 1, and then when we search here, we find that 2 is also less than 3, and we will do, so since 2 is less than 3, we will reduce the the right to 0, but the left would increase to 1. So that's why. So both pointers will cross at this point. Right will go to 0, left will go to 1, and then since both pointers have crossed, the loop will end at that point, and then we'll return left, which will be 1. So that would represent where 2 should have been inserted. So now let's run this. Let's run our solution against the test cases that were provided. There are 3 of them, and 3 of them passed. Let's also go ahead and submit to run against other test cases. Okay, our solution was accepted. So that's it for this problem. Thank you for watching. I'm sure it should have helped. Please click the like button and subscribe to my channel.